Am I audible now? Am I audible now? Okay. Yes. So let me start once again my introduction. Friends, a very good morning to all. I am your friend Ashwarya, expert in GATE, ESC and SSC JEE. I have completed my MTech from IIT Delhi, BTech from Jamia Millia Islamia Delhi. 4 times I have qualified GATE with my best AIR 226. Guys, I do have 6+ years of teaching experience and 2 years of industrial experience, and these are the subjects which I basically take on Unacademy official YouTube channel as well as Unacademy Plus. Theory of structure, RCC and Geotechnical engineering. Once again, welcome you all. Good morning to all. Okay, friends. Okay, Satyam, good morning. Nagappa, Satyam. I think I am audible now. I forgot to turn on my mic. Thanks for reminding. And guys, it is a code #10 which you can apply for buying any Unacademy Plus subscription in order to avail 10% off. Unacademy Plus subscription is running rank improvement batches, dedicated doubt clearing sessions, okay, courses in bilanguage, in English language as well as in Hindi language, okay, and here you are having daily classes, daily live interactive classes on a very interactive Unacademy Plus platform, okay. So you can use this code #10 not only in case of GATE and ESC, but also if some of your friends or relative are preparing for some other competitive exams like CAT, NEET, okay, UPSC and SSC JEE, any exam, any competition exam if they are preparing, even bank service exams. So you can always use my this code #10 in order to avail 10% discount on Unacademy. This 10% discount is the maximum discount which is given by Unacademy officially. Okay, so let's start the session, my dear friends. So welcome to lecture number 21. So today is the 21st lecture, and we about in 2 more lectures we will be able to entering in our core structure analysis. Okay, so we will be needing at least 2 more lectures. So today's and tomorrow's lecture I am planning to take on strain energy method. Okay, and announcement is this, that this week as well, timing for structural analysis will be from 11 a.m. to 12:30 p.m. Okay, and on this Sunday, coming Sunday, we will be having test 11 a.m. to 12:30 p.m. So it is again going to be an interactive test, and syllabus for this test is strain energy method, or you can say slope and deflection, and force method. Force method and strain energy method is going to be a syllabus for the upcoming Sunday test. So test duration is same. Yes, Anku, strain energy conjugate beam. You can, in objective questions you may apply whatever method. Okay. So I'm giving here a heading strain energy method. So obviously I'm going to design such questions. I'm going to give you such questions which can be easily solved by strain energy concepts. Or I'm also going to give you such questions which you can only do by strain energy method in the upcoming test. So in beams or in simple frames, you can use momentary or conjugate beam method. But if your frames or beams is having some curvature and all, then you are forced to use strain energy method only. Okay. So this week our agenda is to complete these two topics in a good manner, in a detailed manner, strain energy as well as force method. Okay. Okay. And yes, one more announcement is there, that on this Wednesday, on this Wednesday, Today is 10th, I guess. So on 13th, 11, 12. No, on 12th of August. I am having a live interactive session, practice session on shear strength of soil. Shear strength of soil. It is a geotechnical topic, and the timing for this session will be 3:30 p.m. to 5:30 p.m. Okay, so this will be on geotechnical engineering. So it is a special session, and platform for this will be Unacademy platform, Unacademy platform, and even for this upcoming test, platform will be Unacademy. By default, for all practice session and live interactive test, platform is going to be Unacademy's platform, and whatever we are reading, learning new things, lectures, that will be on YouTube in the same interface which I am using right now. Okay, a very good morning, Shubhashri Roth. Okay, so we have discussed so far moment area method, moment area method, and conjugate beam method, and conjugate beam method. So this is my email ID, महिमा. आप डाउट तो भेजते नहीं हो, ईमेल आईडी लेते रहते हो बार बार. बहुत सिंपल है. जामिया IITD है ना. जामिया से मेरा बीटेक है और IITD से मेरा एमटेक है. So accordingly I form this email ID. Very simple to remember. अरे अभी अनअकैडमी पे पढ़ रहे हो, अनअकैडमी की बातें करो. ओके, इज इट क्लियर? All are in lower cases. JAMIAIITD@gmail.com. Okay. Yes, guys. So today's topic is strain energy method. Before that, I have to discuss a very little concept of the last class. Actually, I did a slight mistake in the last question. You remember the question of probed cantilever beam with an internal hinge? So we were discussing that. So what was the question? I'll take only 2-3 minutes on this. Please listen to me. This was the question. So this is L by 2 and it was also L by 2. EI was constant. So deflection at D with conjugate beam method, we have got how much? It is 37, I guess, upon 6144 WL4 upon EI. Isn't it? यही आया था. I will take only 5 minutes on this. Yes, it was 37 by 6144 upon WL4 upon EI. This we have obtained by conjugate beam method. By conjugate beam method, CBM, conjugate beam method. Okay, but when I took the same problem with basic, so nothing was wrong in the concept, only a slight mistake was there. So this was the question, and I have broken this question into two parts. One was this, plus another was this. Okay, so this VC was coming out to be WL by 4. You can refer to my earlier lecture. This is WL by 4, and this deflection was coming out to be, how much was that? It was WL4 96 EI. It was WL4 by 96 EI, isn't it? Yes. So this was also going to bend like this. Now due to this UDL, an additional deformation was there. So this was half of WL4 by 96. So it was WL4 by 192 EI. And while calculating this deflection, guys, let's say delta, I have used WL cube upon 48 EI, WL4 upon, which was wrong. Okay, so correct should be, it is a case of UDL, not a point load. So this was the error. So correct would be 5 WL4 upon 384 EI. Okay, now the final deflection is going to be, this one plus this one. So finally I can say that at point D, deflection is equal to WL4 upon 192 plus WL4 upon, what was this? It was 384 into 6144 EI. So now this plus this is nothing but this only. Okay, so what I did on that day, please repeat. I'm repeating here. Instead of WL cube upon 48 EI, guys, it is a case of simply supported beam. If a point load would have been there, in that case that was right, but it was a case of UDL. So this red one is the simply supported central deflection, and this yellow one is the rigid body deflection due to the settlement at sea. So if here it is WL4 upon 96, then at the center it would be WL4 upon 192, half of this, and this additional component is due to the simply supported action. So this is 5 WL4 upon 384 EI. So here L is equal to L by 2. So accordingly, when I added both of them, I am getting 37 upon 6144 WL4 upon EI. Okay, please make it correct, all my dear friends. Okay, great. So now we are starting our today's agenda, which is strain energy method. To calculate slope and deflection. Guys, it is a very powerful method. Okay, and it can be used many ways in your structure analysis. Okay, तो बहुत ही मजा आएगा आपको ये मेथड. और इस मेथड के बारे में let me tell you one more thing, that if you are knowing this method with a beautiful concept, then you will be feeling automatically confident in your structures. Okay, automatically आपको अच्छा लगेगा, स्ट्रक्चर करने में मजा आएगा. So it is going to be like that. Okay, so करें start. Are you all ready? Okay. Some few basics. what is strain energy? Guys, for the next 10-15 minutes you have to only listen. Okay, no commenting, nothing. So tell me, what is strain energy due to axial force? Tell me. Let's say U due to axial force. Anybody? So in strength of material, you derive this expression that strain energy stored is equal to P square ds upon 2AE. And if you are adding them up or integrating them, then you will be getting strain energy stored due to axial force. Similarly, if you want to calculate strain energy due to bending moment, then it will be integration of m square ds upon 2EI. Guys, you might have studied strain energy anywhere, but whatever I am going to tell you, you have to adopt that only. Okay, so maybe on starting you may not be agreeing to me, but you have to trust on me. Okay, so what is strain energy due to shear force? So it is equal to integration of shear force square ds upon 2 ARG. And what is strain energy due to, you can say, torsional moment or torque? So it is IP, or you can say J, polar moment of inertia. So these are the strain energy stored due to axial force, due to bending moment, due to shear force, and due to torsional moment, isn't it? So you can even derive this thing by making the load deflection curve, by making the stress strain diagram. You can know, you know that what is energy stored, it is the area under the elastic limit and all. So by doing that, half into base into height, you will be able to get these expressions. Okay, but those you can cover in strength of material, and I am right now I am focusing only on the application of strain energy method. Okay, my dear friend, like in rigid body physics, what you do for finding the deflection, you know the work done is the dot product of force and displacement. Okay, so work done is equal to energy stored is equal to force into displacement into cos theta, because the dot product of A dot B is AB cos theta. So work done is equal to energy stored is equal to dot product of force and displacement. So if you want to find the value of force, or if you want to find the value of deflection there, then what you do, then there you simply divide your energy with force. Okay, obviously with displacement component as well. So deflection is equal to U by F, energy stored by F, or you can say work done on it by force. So this you normally do in rigid body physics in order to find the displacement. And similarly, if somebody needs a force, then what he or she can do? So F would be equal to U over delta. So this is also correct. Okay. So one thing is sure, if you are differentiating or if you are dividing work done by force, then somewhere you are going to get the deflection, and if you are going to divide work done by this delta, then you are going to get it by force. Okay, similar thing can happen for elastic bodies. First of all, let me tell you this rule is not exactly applicable for elastic bodies. So there, due to elasticities and all, some other parameters will also come into the picture. And about those parameters, Castigliano has told about. So as per Castigliano, if you need deflection at any point, if you need deflection at any point, then that deflection is equal to the partial derivative of energy with respect to force. Okay, like that. Here you are dividing energy by force. So there you have to differentiate for elastic body as per Castigliano in order to find the deflection in the elastic beam. Then the deflection is equal to partial derivative of energy with respect to force. Okay. So I am going to start here with the Castigliano second theorem. There were two theorems given by Castigliano. So Castigliano second theorem. So please write the statement. The partial derivative of total strain energy with respect to load or force gives displacement in the direction of force. Okay, so the partial derivative of total strain energy with respect to load or force gives displacement in the direction of force. So this is the Castigliano second theorem. Let me tell you one thing, that suppose if this is my beam, let's say if this is my beam and you are applying here some load, let's say P, and due to P, let's say the deflected curve of this beam is like this, and if this is deflection, let's say delta, and strain energy stored here will be equal to U due to this P. So then delta is equal to, now the delta is equal to what? It is going to be equal to del U over del P. Similarly, if you want to find rotation somewhere, if you want to find rotation due to a couple M, and due to this, if deflected pattern of the beam is this, and this is the, let's say, slope theta, and energy stored here due to this M is also U, then again you can say that your theta is equal to del U over del M. Okay, so these are the statements which are said by Castigliano. So it is second theorem. First theorem is for force and moment. So first theorem is just reciprocated. So force is equal to partial derivative of energy with respect to displacement. That is first theorem. But right now we are interested in slope and deflection. So we have to go with the second theorem of the Castigliano. Is it clear to all my dear friends? Now my dear friend, one important thing. In slope and deflection, we are calculating slope and deflection only due to the bending moment. So you can see in your moment area method or in your conjugate beam method, who were the main hero? It is bending moment diagram. So similarly, as you can see here, that strain energy can be calculated in the system due to axial force, due to bending moment, due to shear force, due to torsional moment. But by default, we have to give answer for slope and deflection only due to the bending moment component. So whenever I'm going to write strain energy stored, then it means in beams and frames I am going to give only consideration to strain energy stored due to bending moment, not to somebody else. Is it clear to my all dear friends? So whenever I am calculating slope and deflection in my beams or my frames, then by default I have to consider this strain energy due to bending moment, not due to shear force, not due to axial force, or not due to torsional moment. Isn't it? But yeah, if somebody is asking you also incorporate the effect of torsion, also incorporate the effect of shear, so in that case you have to use others as well. But right now it is like this only. Okay, we are going to introduce only strain energy stored due to bending moment. Yes, tomorrow when we will be doing trusses, so there the trusses, the main cause of deflection is axial force. So there I am going to keep this strain energy as an input. So whenever I will be dealing deflection in the trusses, then there I will calculate strain energy stored due to axial force. Because in trusses only axial force are considered, and there is no component of shear and moment in my truss, isn't it? So these two formulas of strain energy we will be using. But right now in beams and frames I will be using this, and when we will move on to trusses, then I am going to use this very first expression written by me here. Okay, now see all my dear friends. My dear friends, let me tell you one more thing. Uh, if you are studying strain energy method first time, then please be patient for at least 3 to 4 questions. So before 3 to 4 questions, don't say to yourself that you are comfortable in strain energy method, because I'm going to show you all the variations in the 3-4 questions. Then you can try your questions by your own. So first 3 to 4 questions I will solve here. I will tell you the varieties, that what you can do with the different load combinations. Okay, because many doubt will arise now that if you need delta, then you need P, then for theta it is necessary to have here M. Okay, so all such answers will be given by me, don't worry. But first of all, for remaining 15-20 minutes, you have to be patient. Okay, but yes, whatever doubt you are having, you can post it. Okay, definitely. If that doubt is going to be resolved automatically, then I will tell you. And if it is not going to solve, and if it is some basic doubt, then I will explain it now only. Okay, so right now I have studied Castigliano's second theorem and strain energy due to various forces, but I am interested in the strain energy due to bending moment, and I have to calculate delta by using the Castigliano's second theorem. So now see here, suppose I am interested in deflection. Suppose I am interested in deflection, and I know that deflection is partial derivative of total strain energy with respect to some force, let's say P. Okay, so P is quite common, so we will make it P dash, because P is the load which usually comes in your questions. So I am making here P dash and M dash. So now what is going to do here? So this will be equal to del upon del P dash into integration of what is U? U in slope and deflection for beams and frames. My U will be strain energy due to bending moment, and strain energy due to bending moment is integration of M square ds. I think this is what I have written. Okay, M square ds upon 2EI. See my dear friends, M is going to be a function of load. M is going to be a function of displacement, because moment is the force into displacement. Okay, so it is going to be a function of load as well as of displacement. So here I have integration in terms of displacement, and I am having differentiation with respect to load. So guys, please let me know, what should I do first? Should I integrate this function first, or should I differentiate this function first? Please let me know. You can do the task in either way. You can do the task in either way. The reason is the integration here is with respect to distance, and differentiation here is with respect to load. So both are independent event. So whatever you are doing first, whatever you are doing second, so it is not going to make any difference. But still, as per my experience, or you can say as per my suggestion, guys, all of us are going to give preference to differentiation over an integration. So you can see So if this is the case, then delta is equal to integration of differentiation of m square is 2m into del m over chain rule. So this is equal to delta is equal to, it is integration of so delta is equal to, it is integration of m del m over del p dash ds upon ei. Okay. So this is the very important expression, and you cannot even imagine that how powerful is this expression. You cannot even imagine it now. No slope and no deflection is there which cannot be obtained from this expression. And similarly, if you are looking for a delta, if you are looking for a delta, in that case, what you have to do, you have to simply differentiate your strain energy with respect to what? Moment. So del over del m dash is equal to m square ds upon 2 ei. Okay, so it is equal to integration of 2m del m over del m dash ds over 2 ei. So this and this will get cancelled. So theta is equal to integration of m del m over del m dash upon ei into ds. Okay. So these two expressions which we have obtained just now are very important expression. And from here we are starting our strain energy. If until here you haven't received anything, then there is not an issue. The all thing you should know is, I am only interested in these two things. First is delta. What is delta? Delta is integration of m del m over del p dash upon ei into ds, and second is theta. Theta is integration of m del m over del m dash into ds upon ei. All I wanted that you all must know these two expressions. Okay, but till now I have only given you the weapons. Okay, till now I have only given you the weapons, but how to use this powerful weapon, this I have to explain you, this I have to train you. Is it okay? Is it okay to all? Tell my dear friends. So shall I proceed further? So for me now, whatever form you have studied earlier of strain energy, calculation of deflection by strain energy, so it's my humble request, don't use that. I am going to tell you the benefit of this approach during the questions only. Okay, so let's start the session with the application of strain energy. Okay. Okay. See, See here. The very first question here is, it is A, it is B. Okay, so you have to tell me deflection at B. Okay, you have to tell me deflection at B. Okay, okay, whatever I am writing now, if you have any doubt in that, then only you can put your question. But please try to control your curiosity, that what would be the case if something is like that or something like this. So that I am going to explain all by my own only. Okay, so this is L. So let's say EI of this beam is constant, and you have to calculate the deflection at B. Only deflection at B you have to concentrate. Okay, so here first of all you can see, so bending moment equation I have to write. So if I am going to write here bending moment equation, so this bending moment equation is going to be equal to M11, and M11 is equal to minus P into X, and X is going to cover from 0 to L, isn't it? X is going to cover from 0 to L. Okay, so why I am having a writing of this limit, now you will realize it. Okay, you might be thinking that I want to do some kind of show off in maths and all. It's not like that. So okay, so why I have used these limits from starting only, this is going to help you now. Okay, see, I need deflection here delta. So delta is integration of m del m over del p dash. So here only one m is enough. Only one expression of m is enough, because that is taking care from 0 to L. That is, it is going to take care from B to A. So only one mathematical function for bending moment is enough. So in place of m, I am going to write here M11. And what is the other thing I need here? What is the other thing I need here? It is del M11 over del P dash upon EI into, and this length is X. So it's small component in the direction of X. I can take it as dx. Okay. And see, my dear friend, the limit of M11 is 0 to L. So now I have to use this limit here. So these limits are nothing but the limits of integration in strain energy method. So that's why from starting only I make your habit in a writing form of limits. Okay, so that's why I induce this habit. I don't know whether it is induced or not, but I try to induce it in you. Okay. And second, M11 is known to me, it is minus Px. What about del M11 upon del P dash? So this is not known to you. And what is del P dash? This is also important to understand. P dash is that load which is acting on a location where deflection is needed. P dash is that load which is acting at a location where deflection is needing. So in this question, guys, I am needing deflection at B, and this P is acting in the direction of delta B. So here the role of P dash will be done by P only. Here the role of P dash will be done by P only. If here P would not have been there, then I have to introduce some other things. What is that other thing? That is my next question. Okay, but right now at the location where deflection is needed, I really have a real load, that is P. So instead of del M over del P dash, I have to calculate del M11 over del P. So here P dash is nothing but P. What is P dash? P dash is the load where deflection is needed. So P dash is the load at a location where deflection is needed. I keep telling you same thing one again and again. Okay, so it is going to have some impact in future. So del M11 upon del P is what? It is minus x. So now tell me, what is the value of deflection? So value of deflection is 0 to L. M11 is minus x. It is minus x. It is dx upon EI. So this is px square by 3ei, 2ei. So sorry, 3ei, px square upon ei. Integration will be px cube upon 3ei. So it will be pl cube upon 3ei. It is positive. It is positive. Is it clear to all? Tell me. Is it clear to all? Now understand few points. This positive or negative, nothing to do with the upward deflection or downward direction. Okay. Okay. Just a minute. Okay. So delta is plus PL cube upon 3I. So I was telling you it is positive or it is negative. So if it is positive or it is negative, it is nothing to do with the upward deflection or downward deflection. My dear friend, here positive means that deflection is being taking place in the direction of load. Here positive means that deflection is being taking place in the direction of load. Okay. Similarly, if this would have been negative, it means that this delta is coming in the opposite direction in which P was acting. So this is plus, see, P was coming in downward direction. So as it is plus, so I can say here that this delta is also negative. Sorry, means in the downward direction. This delta is also in the downward direction. As you all know, what is work done? Work done is the dot product of force into displacement. So means F delta cos theta. So delta is what? Delta is work done upon F cos theta. Isn't it? If theta is 0 degree, it means force and delta are acting in the same direction because cos 0 is equal to 1. If theta is equal to 0 degree, then it is simply W by F. But if theta is 180 degree, means load and deflections are acting opposite to each other. In that case, cos 180 degree is minus 1. So it is going to be equal to minus W by F. So this is what I want to tell you, that if this answer is positive, it means load and deflections are acting in the same direction, and if it is coming negative, it means load and deflections are coming opposite to each other. Okay, so here positive can be upward deflection or it can be downward deflection. Suppose here you have considered positive, so this positive will be downward deflection. Why? Because load was in downward condition. Is it clear to all my dear friends? Is it clear to all my dear friends? Tell me. Any doubts so far? Any doubts so far? अरे कमेंट कर दो भाई, बता दो कोई डाउट है क्या? Okay. Now see. Okay. Now see. So strain energy, if final answer is positive, then it only means that deflection is in the direction of load, nothing else. Okay. So next is same question. Same question. But this time I needed deflection at the center. But this time, my dear friends, I need deflection at the center where C is the midpoint. Where C is the midpoint of beam AB. Okay, so you have to find the deflection at C. You have to find the deflection at C. EI is constant. EI is constant. Okay, so what to do here? We know that delta is equal to integration of m del m over del p dash upon EI into ds. This is what we know. Okay, but now my dear friend, listen to me very carefully. Here you need the deflection at the center. Here you need the deflection at the center and no load is available there. And no load is available there. So what to do here? This method only works if a load is available at the location where deflection is needed. So here you need the deflection at C and no load is available here. So what we have to do here? Any guesses? What can we do here? So here, my dear friend, I can apply a load which is not existing in reality, but it is a pseudo load. So I am creating an imaginary load P dash, but I know in my mind that P dash value is going to be equal to 0. Isn't it? P dash value is going to be equal to 0. But till my differentiation gets over, till then I have to give full respect to this load. I have to think that this load is real, it is not virtual. But once my differentiation will be done, after that what can I do? I can simply remove this P dash from my system. Okay, the task of this P dash is to stretch that component of deflection which is occurring due to P at a location C. So once that component will be extracted, after that we will going to remove this P dash value. Yes, Mahima, you are right. So see, till now differentiation has not been done. So I have to give full respect to this load. So you can see here, this is my section 1-1, and in my section 1-1, my bending moment equation will be equal to M11 is equal to minus X. It is minus B into X and X belongs to B to C, means 0 to L by 2. Why 0 to L by 2? Because P dash is also acting there, and till my differentiation gets over, I have to give full respect to P dash. Okay, so after applying P dash, I have to think it is a real load. Okay, now see, what about section 2-2? What about section 2-2? So section 2-2 is having again a X from here. So M22 is what? So M22 is equal to minus P into X minus P dash minus P into X minus P dash into X minus L by 2 into X minus L by 2 into X minus L by 2. But this is valid when my X is at L by 2 till when my X is at A. Means it is valid from C to A. It was valid from B to C. Okay. So this is del M11 upon del P dash. Because this time this P is not P dash. I need the deflection at C. So I have to take that load for me which is responsible for deflection at C. So since no load was available at C, I have taken this P dash load at the location C in order to compute the component of the deflection. So this is equal to 0. So this is the beauty of doing differentiation over integration. So now you are having this component is 0. So directly you can ignore the first component. Directly you can ignore the first component because it is not going to give you anything. But when it comes to my M22, so my del M22 upon del M22 upon del P dash is minus, this will be 0 and this will be minus x minus L by 2. Okay, this is equal to minus x minus L by 2. Okay, now my differentiation is over. Okay, now my differentiation is over. Now I can keep the original value of my bending moment function. So originally my bending moment functions were M11 was equal to minus px, x belongs to 0 to L by 2, and even M22 is equal to, this will be 0 because p dash is 0 as my differential components are available. So it is again minus p2x, and here as well you can say yes, x belongs to L by 2 to L. So now for getting the value of deflection delta C, what is going to happen? So delta at the center is equal to integration. This time there are two moments responsible for, beam. So as you have to calculate the strain energy of the entire system, it means you have to see the strain and bending moment of the entire system. So this system is having two bending moment function M11 and M22. So no doubt here this is 0, but if this would not have been 0, then my expression would have been M11 del M11 over del P dash okay into dx limit 0 to L by 2 plus integration L by 2 to L M22 into del M22 over del P dash over EI into dx. So deflection at C here is equal to, this I am not going to consider because this component is already 0. This component is 0. So come to this side plus integration M22 is what? After removing P dash, this is the value of M22. So it is minus Px minus x minus L by 2. X minus L by 2 with negative sign. So minus x minus L by 2 dx upon EI. But yes, one important thing here, limits are going to be L by 2 to L. Limits are going to be L by 2 to L. L by 2 to L. So this is delta C. This is equal to plus 5PL cube upon 48 EI. Yes, Mahima, I am coming over there. Del M upon del X. Mahima, I have not taken del M over del X is equal to 0. Please listen to me. I have taken del M over del P dash is equal to 0. In the zone B to C, M11 was equal to minus Px. But I have to do differentiation of the bending moment function in respect to a load which is acting at a location where you need the deflection. So you are not supposed to calculate deflection at B in this case. You are supposed to calculate deflection at C in this case. So at the location C, whatever load is acting, differentiation is always going to be with respect to that only. So here P dash was acting at C, so that's why I have calculated here del M11 upon del P dash, because P dash is the, you can say, responsible load, and this is minus Px, and you are differentiating it with respect to some other parameter, so it is going to be a constant. because we have to differentiate it partially only with respect to P dash, and since you cannot find any component of P dash here, so it is going to be a constant with respect to P dash, so that's why its differentiation is coming out to be 0. And similarly, my dear friends, similarly, here you can see when I differentiated this, I have considered its constant with respect to P dash, so it is 0. Only this P dash is variable with respect to this P dash, so that's why this value will be constant and the differentiation of P dash was equal to 1. Okay, so that's why I have written it like this. Please let me know, Mahima, if it is clear to you. Please let me know if it is clear to you. Is it clear? Okay. So far I have completed 2 questions. First, load at the free end in cantilever beam. Second, load at the central point in the cantilever beam. So again you can see here, here is a positive sign. So positive sign, Rohit is saying, sir, repeat M21. M21 means M22 you are saying? See, I am repeating it again. M11 is minus Px, minus P into x. But P dash is imaginary, but before differentiation we have to consider it real. Okay, so I am going to consider it real now. So it is minus P into x, and the limit of bending moment function is lying from 0 to L by 2. From 0 to L by 2. Okay, why L by 2 only? Because after L by 2 a new load is being introduced. So therefore M22 function I have written minus P into x minus P dash into this distance. This distance was equal to x minus L by 2 was this distance. So this was the function. Okay, and I needed deflection at C, so I have to differentiate my, you can say, I have to differentiate my functions with respect to P dash. We have to do differentiation only with respect to that load which is actually being applied at a location where deflection is needed. So similarly you can see here, जब मैंने ये वाला क्वेश्चन किया था तो मुझे बी पे डिफ्लेक्शन चाहिए था, और बी पे डिफ्लेक्शन के लिए एक रियल लोड मौजूद था पी, तो मैंने डिफरेंशिएशन किया पी की तुलना में, और पी को तोड़ने के बाद मेरे पास फंक्शन बचा एक्स. बट इस केस में मेरे दोस्त क्या हुआ, जब मैंने पी डैश लगाया सी पे, जब मैंने पी डैश लगाया सी पे, तो ये पी डैश ओरिजिनल नहीं था, ये फेक था, ये वर्चुअल था, ये सूडो था, इसका वैल्यू हमने खुद से 0 मान लिया. बट इसका वैल्यू 0 है या ये एग्जिस्ट नहीं कर रहा, ये तब तक हम लोग नहीं मानेंगे तब तक जब तक हमारा डिफरेंशिएशन ना हो जाए. डिफरेंशिएशन होने के बाद, अपना मतलब निकलने के बाद भाई लगा दो यहाँ पे ओरिजिनल वैल्यू, है ना. तो कभी कभी मतलब खोर दोस्त बन जाओ, जैसे आपके खास दोस्त होते हैं ना, जब तक मतलब होता है जब तक साथ दो और उसके बाद भूल जाओ, तो वो वाला हिसाब है यहाँ पे भी, है ना. तो कुछ गलत मत समझना, रियलिटी बता रहा हूँ. तो जब तक आपका मतलब नहीं निकल रहा तब तक पी डैश को यहीं रखो, और जैसे ही आपका मतलब निकला, ठीक है, पी डैश को भूल जाओ. आजकल तो बहुत होता है ये सब, है ना, ये सब तो प्रैक्टिकल है आजकल. तो माइनस पी एक्स लिया मैंने और फिर किया मैंने डिफरेंशिएशन, और डिफरेंशिएशन करने के बाद कितना आ गया 0. क्यों? क्योंकि मैं डिफरेंशिएशन कर रहा था पी डैश के रिस्पेक्ट में, है ना, और ये फंक्शन था पी. और फिर जब मैंने दूसरा अपना मैथमेटिकल फंक्शन लिखा, so this time again I have to differentiate the same with respect to p dash. तो p dash के हिसाब से जब मैंने इसको तोड़ा तो ये आया मेरा माइनस x माइनस एल बाई टू, isn't it? ये आया मेरा माइनस x माइनस एल बाई टू, is it okay? तो जब ये मेरे पास इतना आया, ठीक है, तो मैंने इसको अपने इस डिफ्लेक्शन वाले फॉर्मूले में डाल दिया. फॉर्मूला वही है बट इस बार बेंडिंग मोमेंट फंक्शन दो है, इसलिए मैंने इसको ब्रेक कर दिया लिमिट के अकॉर्डिंग. M11 0 से L by 2 संभाल रहा है और M22 L by 2 से L संभाल रहा है. So this is going to be equal to 0, और ये दूसरा वाला कंपोनेंट मैंने L by 2 से L से रख के इंटीग्रेट कर दिया और आंसर आ गया अब बता दीजिए क्लियर हुआ कि नहीं हुआ। महिमा, रोहित, इज इट क्लियर माय डियर फ्रेंड रोहित? Okay, so let me take 1-2 more examples, then the things will be more clear. Okay, अब देखो, अभी और मजा आएगा जब 5-6 क्वेश्चन हो जाएंगे ना, then you will realize the method. अच्छा, पिछले क्वेश्चन में एक चीज और देखो प्लीज, सी वन मोर थिंग. The final answer was positive. The final answer was positive. What does it mean? That this deflection has been occurred in the direction of load, and where the load was actually acting. The load was actually acting in the downward direction, and final answer was positive. It means that this deflection is also going to occur in the downward direction, isn't it? Suppose in place of P dash is your self creating, so instead of applying it here, you could have even applied your P dash like this. Yes, Barbina, no limitation in this method. It is a universal method. Even you can take the effect of shear, torsion, axial forces during the calculation of slope and deflection with this method. Okay, it is the most powerful tool. बट ऑब्वियसली बात है, जहां सुई की जरूरत होगी वहां सुई लगाएंगे, जहां तलवार की जरूरत होगी वहां तलवार निकालेंगे, है ना. अब देखो, सपोज इफ दिस इज P डैश, इफ दिस इज P डैश, अगर आपने P डैश नीचे की बजाय ऊपर लिया होता तो क्या क्या तब्दीलियां आ गई होती. लेट्स सी दैट. सो इट इज प्लस, ये प्लस हो जाता, ये भी क्या हो जाता प्लस, है ना. ये देखो ना, P इंटू एक्स और ये प्लस हो जाता, और उसके बाद ये हो जाता आपका प्लस और ये हो जाता आपका माइनस. तो अब ये माइनस क्या बता रहा है आपको? अब ये माइनस आपको बता रहा है कि भाई साहब आपने ये ऊपर की तरफ लोड लगाया बट डिफ्लेक्शन नेगेटिव आया. इसका मतलब दिस डिफ्लेक्शन इज नॉट सपोर्टिंग द डायरेक्शन ऑफ लोड, इट इज कमिंग इन द अपोजिट डायरेक्शन ऑफ लोड. इट मींस स्टिल द मीनिंग ऑफ दिस 5 PL³ upon 48 EI is downward. So whatever is the direction of displacement, that is always going to be there only. If deflection has to come downward, it will always come downward. Doesn't matter whether you are assuming your pseudo load in the downward direction or in the upward direction. Is it clear to all my dear friends? Okay, so this negative is also representing downward. Why? Because you have taken this P dash upward, and negative means it is not supporting P dash, so it means it is coming downwards. And in our scenario, what was the real scenario? This was the real scenario. Okay, so now answer is positive. This positive means that deflection is in the direction of load, and load is in downward direction. That's why this deflection is also coming to be in the downward direction. Okay, okay, so be patient, have patience for next 2-3 questions. After that you will be mastering this, don't worry. Now see this, this is a load P. This is a load P, and let's say this is L, it's EI. Okay, it's L, it is EI, and it is A, and it is B. Okay, so this time guys you have to find the slope at B. Question is find the slope at B. Find the slope at B. So what to do here? What to do here? You have to find the slope at B. Guys, see here. When I explained you Castigliano's theorem, see, I told you for deflection, a force or a linear force is responsible. That I can say. If you want to find the delta, if you want to find the linear displacement, then for that linear displacement, linear force will be responsible. And if you are looking for a rotation theta, then for rotational displacement, your rotational force, that is your couple, is responsible. See, you can see delta theta I have calculated due to m dash. So in this question, my dear friend, when you needed deflection at center, you applied a pseudo load at the center P dash. Why you applied P dash? Why you applied linear force? Because you were interested in the linear deflection or linear displacement at location C. Similarly, my dear friend, in this case, you are looking for a rotation. You are looking for a slope. So for slope, who will be responsible? Obviously, due to the bending component of P that slope is generating. But if you are finding it by strain energy method, then strain energy will be looking for a moment at B. Okay, so here I am going to apply a pseudo moment here at B. In whatever direction you want to apply, you will apply. It is M dash. So M dash I have taken in the clockwise direction. It is M dash. And why I have taken M dash? Because as per strain energy, the responsible force for a theta will be a rotational force, which is nothing but the moment. Okay, it is nothing but the moment. Is it clear to all my dear friend? Tell me. Okay, so now see what is going to happen here. Now see what is going to happen. Now write the bending moment function here. Let's say it is M11. So M11 here will be equal to minus Px minus M dash. So x belongs to 0 to L. Okay, x belongs to 0 to L. So what about its derivative? Derivative I can do only with respect to that load or that moment which is acting at a location where deflection or slope is to be obtained. So here I need slope at B. So I have to look for a couple which is actually acting at B. Okay, so couple which is actually acting at B is M dash, and for M dash this P has nothing to do, so it is equal to 0. So the differentiation of M dash is going to be equal to minus 1. Now once my differentiation has been done, after that I have to write the original equation of bending moment function, so that M11 is equal to minus Px, है ना, मतलब निकल गया, अब जिसका काम था उसको छोड़ दिया, है ना. So this method is also known as कलयुग method, जो आजकल होता है, कलयुग मेथड है ये. एक बार क्लास में मैं ऐसा पढ़ा रहा था, मैंने इस मेथड को नाम दे दिया लड़की मेथड, गर्ल मेथड. तो बहुत ज्यादा नाराज हो गए बच्चे, लड़कियां काफी थी, नाराज हो गई. तो मैंने कहा चलो ठीक है, कल से क्या कहते हैं, अब से मैं इसको नाम चेंज करके कलयुग मेथड कर दूंगा. ठीक है, बाकी समझ तो आप गए होंगे. अब देखो इसको इसके बाद क्या करना है. So this is M11. So now the rotation theta at B is equal to integration of M11 del M11 अपॉन डेल पी डैश डेल एम डैश अपॉन ई आई। ये ऐसे लोग और आग लगाते हैं जो ऐसी स्माइलियां भेज देते हैं जिनकी हंसी नहीं रुकती है। फंसते हम जैसे ईमानदार टीचर ऐसे में। तो थीटा बी कितना हो जाएगा यहाँ पे, इट इज माइनस पी एक्स, it is minus 1 dx divided by ei, and limits for this will be 0 to L. Limits for this will be 0 to L, and it is PL square upon 2EI, and again it is positive. It means this rotation is occurring in the direction of movement. It means that this rotation is occurring in the direction of movement, isn't it? Is it clear to all my dear friends? So PL square upon 2EI. आपने clockwise movement माना m, and due to this m the deflected pattern of the beam is like this, and this is the slope which you were looking for. Okay, so this is the bending moment function, and after differentiating this is the value here. So after eliminating the m dash from here, so original bending moment function was minus px. So when I substituted the parameters in my original equation to calculate slope, so then this was the scenario, and as per this was the slope coming at b. So this was the value of theta b, and final answer is positive. It means that this slope is also clockwise, because I have assumed the direction of m dash as clockwise. Suppose if somebody might have taken this value of m dash, let's say in this direction, then the alteration would have been, it is plus 1, it is sagging, it is plus 1, it is plus 1, and overall it is minus. So this minus is also implying the same meaning, which is saying to you that this theta b is acting in the opposite direction of m dash. So here m dash you have taken anti-clockwise, but the reality is that theta is going to be occur in the clockwise direction. So once again I am saying whatever direction will be there in reality, that is only going to come. So doesn't matter whether you are assuming your load in the right direction or not. It is just like the calculation of reaction. Okay, whenever you are going to calculate any reaction, so it doesn't matter what is the direction of reaction you are going to take. If final answer is positive, it means you have assumed the right direction. If final answer is not positive, it means you have to only reverse the direction of the reaction, and magnitude there is always right. Is it okay? Yes, Anku, m dash pseudo hai. Okay, this was the original question. I hope you remember. This was the original question. So due to this P, you have to calculate its slope at B. But ये strain energy method तब तक काम नहीं करेगा जब तक इसको m dash दिखाई नहीं देगा. So that's why I have introduced a pseudo moment m dash at B. Why at B? Because you needed slope at B. अगर मुझे C पे slope चाहिए होता, in that case I would have introduced this m dash at the location C. So okay, just a small exercise for you. Okay. Shashi is saying, sir, one interesting question. Take simply supported beam with two load WW at a distance L by 3 from both support. Find del U over del, and we get additive deflection under both loads. Shashi, in that case, what you can do, see, I will take such problem, but in that problem, what you can do, you change the name of one load under which you need deflection. So that WW, instead of getting WW, you take one W dash, and another you can take W, and you differentiate with respect to W dash, and finally you can substitute W dash to W once your differentiation component is over. By that you are never going to create any mistake. Okay, by that you are never going to create any mistake. Okay, let's see what Shashi is saying. Okay, so you know now. Okay, then it's okay. Tomorrow I will take that problem then. If you know, then it is okay. So our Shashi friend is very intelligent. So friends, you do a question for me. This is C, center L by 2, L by 2. And you have to find the slope at C. Okay, slope at C. Then Shashi, tomorrow I will take that question. Okay, because it is going to break the sequence. And there are lot many things which I have to tell additionally in simply supported beam, because the effect of pseudo load is also be considered in the reaction and all such things I have to explain them. Okay, post your answer. Post your answer. Okay, I am also doing it slowly in tortoise speed. Since I needing slope at C, so I am considering a pseudo moment m dash. So there are again two functions of bending moment. So here m11 is minus px, and this x you can use from 0 to L by 2. From 0 to L by 2 you can use your x, means you can say from B to C. But if you are going to differentiate m11 with respect to m dash, then you are going to get nothing. It is simply equal to 0. But when I am writing my m22, so it is equal to minus px minus m dash, and x belongs to, you can say, L by 2 to L, means from C to B. And if you are differentiating this del m22 with del m dash, so this is equal to minus 1, as you can see here. Now, so I'm waiting for your answers, dear. Please post your answer as soon as possible. So now what to do? Now deflection at C, sorry, slope at C will be equal to integration of m11 del m11 upon del p dash del m dash 0 to L by 2. Yes, Mukesh, you are right. L by 2 to L. So this is not going to participate, as no component can be extracted from this side, and theta c will be equal to L by 2 to L So m dash you can put 0 now after differentiation, minus px minus 1 dx over ei. So it is equal to 3pl square upon 8ei. So positive sign is just indicating that yes, Mukesh, Rohit are right. Positive sign is just indicating that here the slope is going to occur in the clockwise direction. In the clockwise direction. So this is slope. Okay. So this is the slope theta c. Okay. So this is the final answer here. I hope no doubt is here. Keshav is also right. Good. Okay. So shall I give you some questions for practice today? Okay. So please practice these questions. So today I will restrict myself only up to cantilever beam. Okay, I will restrict myself only up to cantilever beam. So it is W, A, B. Find all those four things. So it is 4 questions. Find theta A, theta B, delta C and delta B. Sorry, it is 3C. C is the midpoint. C is the midpoint. It is C, it is L by 2, L by 2 and EI is constant. Okay, one problem you can try which Shashi was saying. Shashi, you can also tell me the answer tomorrow. That is equal to, there is a point load, 2-point load. One is acting at the center and one is acting at the free end. So both load are same, P and P. And distance here is L by 2 and L by 2. So guys, only tell me the deflection. Tell me the deflection at B. Tell me the deflection at B. So this is 4 plus 1, 5 questions I have given you for assignment. But yes, obviously you have to use the strain energy method because I know you all know the answer of these 4 cases. We did it by moment area and conjugate beam method. So try to do this. Okay. Rohit, what can I do? I was acquiring 2 sessions for strain energy. So I will keep tomorrow's session on strain energy and even I will extend one session on strain energy. So in that time, I will be adding something, some questions, okay, for superposition. So, okay, what can I do? So tomorrow and day after tomorrow, I am keeping it for strain energy. And after that, we will be discussing superposition. Okay, before starting our force method. Okay, before starting force method I will take a session, don't worry on that. Okay, so there are 5 questions, please do in that. Okay, so if any doubt then please let me know. And yeah, if any one of you is interested in Unacademy plus subscription, guys, which is having all these facilities, okay, it is having daily live classes, crash courses, you can see rank improvement batch. It is in bi-language, you can say, in English and Hindi. It is having a dedicatedly doubt clearing session. Every 4th lecture in our Unacademy Plus is the doubt clearing session. And apart from that, it is also having weekly test. Then guys, you can download this Unacademy Learners app and you can select your course, duration of course, and please use my code if you are looking for an Unacademy subscription. So by using my code directly you will be getting benefited of 10%. So 10% benefit you will be availing by using my code. Okay, any faculty code you are using, you are going to get 10% only, which is fixed by Unacademy. But if you want to support me, then promote my code. Okay, so thanks a lot my dear friends. Have a great day and don't go outside if it is not required. Stay safe. See you soon and remember the announcements that day after tomorrow we are having a session on shear strength of a soil practice session, and on Sunday we are having a test on slope and deflection, that is by strain energy method, and apart from that force method. So these are the topics. So thanks a lot, my dear friends. Have a great day ahead. Enjoy. Have fun.